Okay, intro to me. Who cares? None of you care. You either already know me or you're not here to know about me. So, but there is one detail that you need to know about me, and that is I am an international man of mystery. Specifically, I lived in Norway for a couple of years, and that is relevant to the talk. So, there's a couple of things that I learned while I spent time in Norway. Norway is a beautiful country, has incredible natural resources and natural beauty. I've been to 3 of these places, and the one in the lower right is even more impressive when you're standing there on that cliff. That's called the pulpit, and apparently you get to preach to that whole fjord. I also learned that Norwegians are wonderful, patriotic people. They are beautiful and friendly and kind. And, you know, this is sort of what it looks like on May 17th. That's their Independence Day. They dress up in these wonderful national costumes. They're not, hopefully the snow is melted by then, but maybe not. And they have flags out. And I learned that Norwegian, the language, is stupid. It's really unfortunate. I don't know how such a great people came up with such a stupid language. It's really sad. So here's some examples. Justin har geitos I håret sitt. And so I will literally translate this for you. Justin has goat cheese in the head his. Obviously that's totally screwed up. I've highlighted some of the errors, I'll call them, that the Norwegians made. The introduction of the definite article, the reversal of his and head. This makes no sense. Hvor kommer du fra? That is, where come you from? If one of you came and asked me that, I would run away from you as fast as I could, or prepare to defend myself. And lastly, Justin saw norsk dum. And that translates roughly to Justin said, quote, Norwegian is dumb. And you'll notice that, I don't know where they came up with the double angle brackets, but that's clearly wrong. Isn't it? We all know that that's wrong. Just straight up. There's really no argument about that. I hope by now the whole country of Norway knows I am joking. Thank you. And Minnesota, sorry. I am joking. I love Norwegian. It is difficult to make a value judgment when you don't really know the language. And in fact, I had a lot of those similar thoughts that I actually just vocalized when I was learning Norwegian. Like, boy, this is dumb. And as I progressed and learned more and more, I realized that actually Norwegian is a really great language. It's highly phonetic. It's very composable. There were a lot of times where I would be speaking with somebody and I didn't know if I didn't know exactly how to express a particular thought, but I knew that if I could just jam a couple of words together, that would roughly get it across. And then I would do that, and people would look at me like, oh, your vocabulary is great. Awesome. There are very few special cases, far fewer than English, and there's a lot fewer verb forms and so on. It's only spoken by about 4 million people in the world, so it has its cons. But as a language itself, it actually is really great. So trying to judge the language before you really understand it or can speak it is a difficult proposition. Difficult to judge value when you're ignorant of what is there. So why this whole lecture? Here it is. Clojure is a Lisp on the JVM. So, boo, yes, come on, let me hear the reaction. I'm looking for that strong reaction. Parentheses, oh, good, thank you. Okay, so I will just, we had to give a nod to the subtitle here, so we'll just launch this for a second. This is from Dr. Strangelove.
Our premier is a man of the people, but he's also a man. What did you say? I said Premier Chekhov is a degenerate atheist.
Wait for it. And there it was. So, no fighting in the war room, okay? We're in the war room. This is actually called the Coliseum, so don't egg me. No, we don't need to see it again. There we go. So, before we get into this, don't fear the parentheses. So, on the top we have some Java code. On the bottom we have some Clojure code, and these do roughly the same thing. In fact, they do, I think, the exact same thing. Okay, so is everybody taking that in? Yes. Is everybody smelling all of those parentheses and just has that ghastly whiff to it? They're actually not that different. So on the top I've got some Clojure-ish Java, and I've just sort of rearranged the punctuation. And I've got some Java-ish Clojure on the bottom, and I've just, again, rearranged some white space. I can pretty easily make one look like the other. Now, there is still this problem of that opening parentheses on the bottom there, right here, but we'll just ignore that for now. So the two languages are, when you look at them, are not that different. And we'll talk about why there are so many parentheses, why that actually turns out to be an advantage when you get to know the language. When the first half of this talk is over, you will know the language. And so the first half will cover Clojure in 8 easy lessons. Second half will be all about the sales pitch of why Clojure is awesome. Normally we start with that. I imagine you guys want to just jump straight into the gory details of, so what is the language? And then the last part, the last half, will be about getting started with Clojure. I can't guarantee that all of these halves will be equal, so don't go all mathy on me, please. I appreciate that. Okay, Clojure in 8 easy lessons. So lesson 0. Clojure is a homo-iconic language, and all the processing is done in a read, evaluate, print loop. So let's break that down. Homo-iconicity is a really fancy word that I think only Lispers use for saying that code is data and data is code. Someone once said to me that in Clojure we code in data structures, that there really is no difference between data structures and the code used to process those data structures. The REPL is the process by which Clojure itself reads characters and creates those data structures. The evaluator, so that's what the reader's responsibility is. The evaluator's responsibility is taking those data structures and evaluating them. And we'll talk about more about the evaluation process in the coming lessons. And then printing, I'm not going to explain printing, and nor am I going to explain looping. Really, the key concepts there are the reader and the evaluator. Often we'll hear the REPL referred to as some sort of manifestation of the REPL, and that exists. So right here, I'm sorry that we're on a Windows machine, but be that as it may, this is a representation of the Clojure REPL. So I'm going to just type in here some plus 2 and 2. This is a Clojure expression. I'm going to hit enter, and the reader will read that and then evaluate it, print out the resulting value, and then loop back. So this is a manifestation of the REPL. When you're running in the non-interactive mode, the REPL still exists. One interesting thing about Clojure is that it is a dynamically compiled language. It does compile, like what I just typed in, was compiled to bytecode and is run. And that all happens dynamically. Clojure is pretty smart about when it chooses to do that. And you can choose to do what's called AOT, ahead of time compilation. What we did right here was dynamically compiled using the compilation library or APIs that were added to Java in, I think, 1.6. So that is the REPL. So, and those two things sort of form the foundation on which the rest of the lessons are built. We have code as data and data as code, and we have a read, evaluate, print loop. So we can then move on. The next fundamental, lesson 1, is data structures. And really we're going to focus, for the purposes of this talk, on 3 basic data structures: lists, vectors, and maps. And you can see the notation used here. And here's some examples. There at the bottom, this is a list used with the parentheses. And then that second one is a vector, square brackets. And then the last one is a map. Now, if you look at that, it looks similar to that, but it maps this to the is and a to map. The other two, a list you can think of like Java util linked list, and vector sort of as an analogy to Java util array list, where you can do direct indexing. And then a map has the normal key value semantics of Java util, map, and implementations. All of this forms the basis of EDN, and that is a data notation specified by the authors of Clojure, and it really uses this as its basis. So here is some examples of a data structure. What does this look like? Does this look familiar to anybody? It looks like JSON. That's exactly right. With a slight tweak there, it becomes valid JSON. And so that notation shouldn't feel all that unfamiliar. I mean, it is like coding in JSON, sort of. There are some different notation used. So if we go back, in Clojure, for example, the commas aren't necessary, the colon isn't necessary, but it really is very, very similar notation. Okay, any questions about that before we move on? Lists, vectors, maps, and that forms the notation foundation of Clojure and really all Clojure programs. So lesson 2, we have data structures. We have those 3 basic data structures. What can go in them? And that's what we'll talk about. And there's really not that many things that can go in them. And it's the stuff you see before you here. And we'll talk about each one of them a little bit. But I will say it is worth noting that Clojure is a dynamically typed language. So in this you will not see double or float or any notation about what the type of a particular literal or symbol or keyword is. But interestingly, and we won't cover this in this talk, there are ways of doing type hints. So you can do that. Clojure has this notion of metadata that you can embed within your data structures to say that, well, this thing is actually a string. So you can give type hints. So let's go on. So symbols in Clojure are like symbols in most languages. There is a slight difference in the characters that you can use in a Clojure symbol, but really symbols act in Clojure the way they act in other languages, meaning when a symbol is resolved, when it's evaluated, it gets resolved and it points to something else in a symbol table. And the examples down there at the bottom are all idiomatic Clojure. Normally you'd say a function, single word, all lowercase. If there's multiple words instead of camel case, you would use dashes. And if you have some sort of predicate or something that is in terms of Boolean, you may choose to end that with a question mark. That's symbols. Then there's a host of literals. Most of the ones that you would come to expect. This Clojure is a JVM language and leverages that heavily. So strings in Clojure are Java lang strings. They're the same thing. If you did instance of, you would, or type is the function in Clojure, you would get Java lang string. Same thing with characters. That notation, that backslash, may feel a little funny, and we'll get to that in a minute. But that is how you have a character literal, and they are Java lang characters. We have numbers of both standard and arbitrary precision. So 1 is just an integer. 1n is, well, it's not a big integer. It has its own, Clojure has its own implementation called big int, but it is an arbitrary precision integer. Same thing goes for floats or doubles. So you can have float or double decimal literals, and then the m notation afterwards is an arbitrary precision. I think in this case it is a big decimal. And then lastly, there are rational numbers in Clojure. So 22/5 is a rational number, 22 over 5, and you can represent that directly or ask that a floating point number be rationalized and turned into a rational number. So, and so you can have those as literals, and you can operate on them. Obviously, then there's Booleans, and then nil, which equates directly to null in Java. Next, we have keywords, and keywords are kind of like symbols, but they're prefixed with a colon, and they're simple and seemingly unnecessary, but they are in fact awesome. As you're writing Clojure code, it's great because you can sort of treat them like enums, or it makes your Clojure code very readable because you don't have a string that is a key, you have a keyword that is a key. And I know that as I'm saying that, you're thinking, that sounds like lunacy. But actually, as you write Clojure code, you will start to realize, oh yeah, these keyword things are pretty handy. So if you see something that looks like a symbol but is prefixed with a colon, that is a keyword. It doesn't get resolved like a symbol. It's just sort of like a string that's not a string. So, okay, so quick review. Code is data. Data is code. And it all runs in a REPL. We have some basic data structures: lists, vectors, and maps. And then there's a bunch of stuff that can go in those lists, vectors, and maps. And one thing I didn't mention that's mentioned here is that other data structures, other lists, vectors, and maps, can be nested ad infinitum within Clojure data structures. So a lot of Clojure looks like this. On the left-hand side, we have a map. And here we have the keyword ID mapped to some symbol. The keyword list access list maps to a vector of integers. And then the keyword prop map maps to another map that may represent some sort of properties, like this person, I guess, represents an administrator. And there's no blacklist. So on the right-hand side, there's more code or data. Code or data. So we have a list, and we have this def symbol, and we'll actually come to that pretty quickly. That's a special symbol. And then my data is a symbol, and then on and on and on. And I think that you probably can start to read that from there. We have a map that is mapping keywords to various things. One thing I do want to point out that we'll come to, there's this tick mark right here. Let's see if we can get to it. This guy right there. What is he doing there? Makes no sense. And we'll come to that in less than 5, I believe. So hang on. But everything else should seem pretty standard. It's all lists, vectors, maps, which brings us, this specific example brings us to the next lesson. And this is actually a syntax lesson. So lesson number 3, items in an unquoted list, and let's just set aside that unquoted bit for a second. Items in a list are evaluated specially, and they're evaluated using call semantics. So when you have a list, the first item is the operator or the function, and I use both of those in quotes, and I will use air quotes now because Clojure doesn't have operators, has functions, and it has more than just functions. It has special forms and macros, and we'll get into all that. Subsequent items are all of the arguments to that operator or function. And that is how call semantics work, period. So here's some examples. We have something in Clojure called special forms, which will be lesson number 4. And in this instance, we have an if. So the operator is if, and it has these arguments. And you can probably guess what this will do. It will evaluate that first argument, true, and if it is true, it will return the third item in the list. If it's false, it will return the fourth item in the list. So that third item in the list is the true branch, and the fourth one is the false branch. Then we have the notion of macros, which are, we'll get to that in a minute. But in this case, we are defining a function called add that takes 2 parameters, and then it just adds x and y. But again, the same call semantics exists there and apply. So obviously, defend, the macro defend takes a symbol, and then it takes a vector, and the understanding there is that the symbol is the symbol for the function, and that vector is supposed to represent the parameters to that function, and then everything else is the body of that function. And then you have an actual function. So plus in Clojure is a function, and in this case, this thing's going to yield 6. That expression will evaluate to 6. And then the last one is just invalid, because it will attempt to use the call semantics, and it will grab the literal for, and it will say, well, what do I do with this? This isn't a special form. This isn't a macro. This isn't a function. I don't know what to do, and then you actually get a runtime exception. So, respect to the call syntax. Any questions about that? Good. So lesson 4, we'll move directly into special forms. And these are the language primitives. These are the forms that really everything else is boiled down to. They are evaluated specially, and like I said, they're the building blocks for really everything that comes afterward. So you have, and really, what's over on the right-hand side there really represents most of the important special forms. It's pretty amazing that we can boil the language down to just that small number of special forms. So there is some, I don't want to say tricks played, but Clojure leverages the fact that it is a hosted language on the JVM quite heavily to make this happen. But this makes for a really concise core. So here's some examples. We already saw if. This will yield true. One comment here. The semicolon is a single line comment in Clojure. It's a special character. But in this case, the REPL would return to you the keyword true. All right, moving on quickly. So def is another special form. It's how you define a new symbol, and you can optionally assign some value to that symbol. So in this case, I'm defining the symbol X, and I'm going to assign it a value of my symbol. And then what you get back is a reference to X, this newly created symbol. And we will see. Okay, let is a special form, and it allows you to define a local symbol. In this case, val is a local symbol. Right here, this guy is local to this let expression, and it's set to, in this case, nil, because this if is going to go down this branch, and it will be set to nil. It's also worth pointing out that in Clojure, nil evaluates to false, so we will get pick me. And another special form that you'll use fairly often is FN, and that is the way to create an anonymous function. So this is the way you create an anonymous function. And you know, obviously this will just execute a Boolean statement. Now, bool, don't get fooled by bool here. This is not some sort of type hint. It's just a name. It's just a symbol. I should have just called it Q or something to make it less confusing. That is a symbol. There's no type associated with that. And then what you get back is this notion of this anonymous function that will do this if statement for you. And then we're going to combine a few of those together. So we can combine a few of these together and then also show the Java interop special forms. So we define myFN, and then we define the anonymous function. So we're going to associate a symbol with a function. It's starting to feel like programming. And then you'll notice down here that we have throw and new, and those are Java interop special forms, and they're specifically so you can obviously create new Java objects, throw the given exceptions, and in this case, if you were to pass in an argument that evaluated to false, you're going to get an exception. And it's going to just instantiate a brand new runtime exception. And this is maybe the first time we're starting to see what people start smelling with a Lisp here. All of these ending parentheses. Oh, actually, with a great editor, that is cake to manage. And so we'll just cruise through the interop special forms because they're pretty straightforward. I mean, if you program in Java, this will start to make sense. So remember, Clojure strings are Java strings, so you can call all the methods that you want on a Clojure string. So 2 uppercase yields the string uppercase. So what you do is use that dot notation, then the method, then the object on which you're going to operate, and like we see here, any parameters to that method are just passed at the end. And then the same goes for constructors. So these 2 things here are equivalent, and we'll get you a brand new date. Apparently, I did this 10 days ago. And then the same thing goes for passing arguments to constructors. So, questions about any special form? Yes, Joel.
How does it know the atomic and are those just special, like the document game?
Yes.
That's just special globally available stuff, or
does
it know operate on?
So using that dot special form, that when you begin with a dot, it evaluates that specially. So it says, okay, what I'm expecting after this dot is a method name. And then the next thing in the list, I'm expecting that to be an object. In this case, it's a string. So then that's where you get that context. And then I'm expecting if there's anything else, well, they're going to be all the arguments for that method on the object that was the first parameter in that, or second item in that list.
So when methods detect as operators, can you conflict them?
Right. Right. Yeah, it feels sort of Clojure-ish when you use this notation. You can still use objects from the JVM, and in fact, this is one of the great virtues of Clojure and how it was able to get ramped up so quickly. So Clojure is only about 5 years old and has libraries for virtually everything because you can take some Java library and slap an idiomatic Clojure interface on top of it, and voila, you're done. You're done. And in fact, a lot of the libraries, if you go look at the code, are really straightforward libraries because they're just passing through to say like Joda time or the AWS, the Amazon AWS client like SDK, or really any other Java library that's out there. So that was special forms, and now we're going to take a little detour and talk about reader macros. So we talked about the reader and how it was its job to read in characters and turn those characters into data structures. Well, reader macros are built in into the reader, and their purpose is to recognize certain characters and then expand those characters like you'd expect a macro to do. So in this case, when we saw that quote, several slides ago, the quote will do this exact evaluation. So the reader will take that quote symbol and wrap whatever's following it in quote, which is a special form and means that whatever's inside of that will not be evaluated. And then the hash symbol is a dispatch special character, and it has a variety of uses that you'll see. But the one that I wanted to call out here is that if you just use hash and then a parentheses, an opening parent, then what you've done is done shorthand for creating an anonymous function. And so it will expand to that stuff that's there on the right. It's important to understand what reader macros are, because when you get into it, it's this, you have a Lisp and it's nice and pure, and then you have all these random characters seemingly throughout the code, and you think, well, now I've got to memorize all this stuff? You just totally hosed the whole joy of the Lisp here. But actually, there really aren't that many. And if you know ahead of time that you need to be aware of them, then when you see them, you'll be able to say, okay, that character is out of place, must be a reader macro. And I need to just go look up and find out what a reader macro does. And really, the two that I've listed here are the two that you're going to encounter most often. So, okay, back from the diversion. Now we'll talk about just regular macros. And these are macros that you can write. And the Clojure macro system provides a way of essentially creating compiler extensions. So you can create, or library writers can create on your behalf, essentially new special forms. And you can essentially, like it says here, create your own Clojure primitives. And what's interesting is that if you start digging into the Clojure special forms themselves, some of them are actually implemented as macros. So the macro system and the special forms are really symbiotic and form the basis on which your own functions and macros are going to be built. So this is just an FYI. If you've never written any Clojure before, don't write any macros. Period. Just don't do it. Now that I've said that, of course, you will go do it. And it's been said several times by other speakers that have talked about macros that one of the reasons to write macros is pure awesomeness. To do something just because you can do it. Well, when you're learning Clojure, that can bite you really quickly. So they're interesting to investigate, interesting to learn about. But if you're going to write actual code, you intend to do something, you should just wait. I pulled this quote directly from the Clojure website. Macros should be reserved for situations for which functions are insufficient, and functions will go a long, long, long way. A long way. And really, it's only if you want to create your own DSL, or if you want to create your own control flow, or if you need to be able to do assignment or symbol creation that you want to associate with the operation at hand, then you start talking about creating a macro. But functions will go a long ways. And functions have some benefits that macros don't have, even though they, on the surface, sort of seem, as you start reading about them, they will seem similar. So here's some macros you'll use. And is a macro, when is a macro, and really when is just a one-legged if and I won't even bother talking about it, apparently. Def-n is a macro, and we saw this before. And then cond, it will allow you to go through a series of conditions. And assuming the symbol is resolves to ninja, then you're going to get awesome from that. So finally, we are on the last lesson. We'll talk about functions. And probably at this point, this is going to feel very natural. The creation of functions is going to feel very natural. But I do want to highlight some characteristics of Clojure functions. So they are first-class citizens in the Clojure world, meaning you can pass a function around just like you can pass an integer around. They support some overloading. They support recursion. It would be sad if they didn't. They support var args. And you can do closures. That's closure with an S, meaning you can partially apply functions and you can wrap context inside of the function and then pass that around. And you'll find as you get into Clojure, a lot of Clojure libraries, they can be remarkably concise because they make use of higher order functions. And higher order functions, you probably already know, are functions that either produce another function or they accept functions as arguments. So, for example, there's a great library called Ring, and it is that provides the basis for the HTTP support within the Ring, within the Clojure web stack. It's not really a part of Clojure, but it's what most people who write Clojure web stuff is all based on. And it's essentially all higher order functions. And lastly, Clojure goes to great lengths to allow you to write pure functions, meaning functions that don't have any side effects. Meaning, given a set of arguments, it will always return the same value, and it will have no effect on the outside world. And that is one of the awesome things about Clojure. Now, as a side note, special forms and macros cannot be passed like functions are. That they are not. You cannot have an if participate in some higher order function. Functions in Clojure are special that way, and are designed to be able to participate in all the things that I've just talked about, whereas macros and special forms are not. So all together now, here is some Clojure code that demonstrates most of what we've just been talking about. And a lot of times, as you see this, you will realize in Clojure that a lot of times you have to read inside out and sometimes bottom to top. It takes a little getting used to. But in this particular example, I've created a new namespace. Namespace is a macro that exists, and I'm not going to go into namespaces, but this is in its own namespace. And the purpose of all of this is to create one of these maps right here, one of these maps, which is a single feeding entry for an animal for a given day in a particular month. And what we see here are keywords being used galore. Ram to nth is a function that's available in the core library, and we see the notation right here to create an anonymous function that I'm going to pass to the repeatedly function, which will just do that thing over and over again, and presumably for side effects. And we will see down here all sorts of functional sort of programming. So we're going to partially apply this daily feeding entries function with animal, and then we're going to call mapcat, which is just like a regular map function, meaning it's going to apply that this function here, this partially applied function, to every item in the resulting sequence that comes out of this dates and month function. So it's going to take a function and it's going to apply or it's going to take a sequence and apply a function to every member of that sequence. And mapcat just, if you have nested structures, it will cat them together so you can flatten it, at least one layer. So any question about this code? Anything that you're wondering about, or you look at it and think, okay, what he said doesn't make any sense as I look at this? Great. Nice. James?
Will that run, or is there some like entry point? We haven't seen?
So if this were loaded and I was using the REPL, then I could call any of these functions. I could import them. And I'm not going to talk about like project management, like Clojure project management, but yes, you could create essentially a main method, an entry point that could call this. And in fact, that does exist in the project from which I pulled this. This is from a little project to generate a bunch of test data for some storage experiments that we're running at Clearwater. So yes, this you could call these functions on the REPL, but there is no main here. The assumption is that there's some main elsewhere that will call this. Any other questions? Yes.
So that partial down the bottom.
Yes.
Do you think what that's doing really quick?
Sure. So partial is a higher order function that takes a function and takes an argument to a function and then applies it. And the assumption here is that the daily feeding entries function, we can see that right here, actually takes two parameters. And so we partially applied the one parameter. So the assumption is that the resulting function now only takes one parameter.
So is this like creation or raising?
Yes. Yeah.
Can you walk me, I understand the names, but can you walk me through the requirements?
Oh, sure. So that part in Clojure has been a little in flux, but what it says here is that it requires the animal-data.date namespace that is required by code that follows within this namespace.
And it's not defined here.
It's defined elsewhere. And then the refer allows me to just refer directly to this one function rather than doing a namespace qualified function call. So there's ways to do, you can do refer all, and you can also say I want to require a namespace and I want to rename it to S or D in this case. Maybe I would choose. So, and I want to talk about. I'm going to intentionally leave off all the semantics around doing namespace qualified function calls because that'll probably feel pretty natural as you start getting into it. But yeah, that's what that's doing. Other questions? Tim, you don't have any questions? None. Got it. Jared, do you want to heckle?
No, I'm saving them all for the end.
Okay. All right.
I've
Good.
been trying hard not to.
Excellent. So just to review, so first of all, you now know the language. You now know really all the rules you need to know to be able to write basic Clojure. There's no tricks up the sleeve. There are a few things that I didn't talk about, like namespace qualified symbols. And there's certainly quite a number of functions and macros and a few special forms that I didn't talk about. But none of those will jut out of these bounds that we've set. They're all going to obey the syntax and the semantics described here. So REPL and data as code as data, basic data structures, maps, lists, vectors, symbols, and all the other stuff that can go in those data structures, the call syntax, and then the things that you can call, special forms, macros, and functions, and then you've got this sort of offshooting thing, the reader macros, which are these weird symbols that don't feel very lispy. So now you know the language. You know it. You could go and do. So now I want to talk about why Clojure is awesome, and we'll cover that pretty quickly. But here's a lot of awesome stuff I didn't cover. And really, this isn't language. This isn't syntax. There's really only really one bit of syntax up here. This guy right here. That's set notation. That is syntax. All of the rest of the stuff is going to fall into all of those rules, which is fantastic. And there's a lot of great stuff here, and some of it I'll cover, some of it I won't. But we'll just carry on. So now that you know the language, the next thing you need to know is what is at my disposal now that I know this language. And the place you start is Clojure.core, and at the very end I give tons of links to go find the documentation for all of that stuff. But Clojure.core is a vast namespace, and it is implicitly imported into everything that you write, so you have it all available to you. And it's definitely worth exploring, and really all of the math functions, all of the Boolean functions, all the bitwise stuff, all of the higher order function, or most of the higher order function stuff is in there. Dynamically creating collections, maps, lists, vectors is all in there, along with map, reduce, filter, sorts, and then on and on down the line. So really, now that you know the language, you need to go explore that, and we'll talk about how to get started in a while, but you need to know Clojure.core and really understand what is available, because you'll be able to leverage the syntax you now know, and then make use of all this stuff available to be able to do really all sorts of pretty cool stuff. So now let's talk about why I think Clojure is cool, and sort of what led me to start investigating Clojure. And where it started was just a frustration with object-oriented programming. And maybe object-oriented programming, the way Java has forced me to do it for years. And for a long time, I just felt that was awesome. It was the way. And then I realized I have to find a stupid noun for everything I want to do. I've got a data set. Okay, well, we better have another Pojo. Hallelujah. And then it just sort of got a little frustrating, a little tedious. Boy, but every time I have a new data set that we get from, that we get out of the database, I gotta go figure out what I'm gonna call it, and it doesn't clash, and then I've got all these methods, and then I've got to, if I want to do something with this structure, I then have to write all the code to do something with it. And so that was pretty frustrating, and sort of led me to start looking around. And I looked at Clojure, or at Scala and Clojure, and then started realizing that in that a great talk by actually is the author of Clojure was recommended to me, called Simple Made Easy, and I've got a link to it at the end of the presentation. And if you haven't watched it, you should watch it. It is a fantastic talk. Just almost as a sidebar in that talk, he talks about things getting complected, or things that don't need to be wound up together, getting wound up together. And in this case, he mentions that state within an object combined with methods equals big mess, because you're conflating all of the things you want to do with your data with the state of the data itself. And Clojure's response to all this is, we're going to let data be data. It's going to be maps, lists, and vectors. And what you're going to do is have just a very few of those types, and we're going to have a whole bunch of functions. Lots and lots and lots of functions. So if I have data that needs to be represented, I create a map or a list or a function, and then I have a whole host of libraries to actually manipulate that stuff. And that was really appealing to me. At first it was sort of like, oh, but I don't have a getter method. What if I say need to hide access to this? And then I realized, well, most of the time I'm just protecting myself from me, and I do a poor job of that. And a lot of times what I end up doing is putting something ooky inside a getter or a setter and doing something that I really shouldn't be doing to the state of that data. And I realized, well, okay, maybe data can just be data. Pretty interesting. And then I started realizing as I was exploring more and more that, as you can see, in 8 lessons, I taught you Clojure syntax. And that feels very liberating. And I would say that Java syntax is not overly burdensome, but it is certainly more burdensome than what we just experienced. And what's great is you have this low mental overhead while still being a general purpose programming language. And it's great because you get to start thinking, you don't have to think, well, okay, how do I do, what's the syntax for X, Y, or Z? I have to remember that. There is mental overhead in understanding what functions I need to call and what few types are available, but I have to know that in really all languages. And I get to concentrate on the domain problem at hand rather than how I make the language fit into that and jamming it in and trying to understand syntactically what I need to do to get the language to help me finish the job. As I've written Clojure code, what I've noticed is that some of the characteristics mentioned before about functions really make testing, unit testing, like real and actual testing of units. Because if you strive to write pure functions, you live in a world without side effects on the state of the data. And you get to test functions, not methods plus state, and you don't have to mock a bunch of objects. You just create input data, and then you test output data. What is the value I got based on this input? And that is also very liberating. And what I realized is that because of that, we continue to say don't repeat yourself. And what I realized in Clojure is that don't repeat yourself for long. Because testability is so easy, and what you're dealing with is just pure functions. If you're halfway disciplined about it, you can repeat yourself for a little while until patterns emerge within your code, and then you refactor. And then it's actually like mathematical factoring. You start actually just pulling chunks of code out and combining them together, and you're not worried about state getting messed up somewhere. And then lastly, immutable data. And it maybe takes a little while to get why this is the secret sauce or one of the secret ingredients in the sauce of Clojure. But all of the data structures in Clojure are implemented, they are immutable, persistent data structures, meaning that they have, I guess, a copy on write semantics. So if I pass a map to a function, and then I put stuff into that map, it has no effect on the outside world. The person, the caller of that function, still can see the original map and the state of the original map that it passed to the function. If I then, inside the function, put a few extra keys, and then pass that resulting map out, as far as the caller is concerned, they see two things with two different states. And that underlies so many things in Clojure and enables so many things in Clojure. The ability to write pure functions and be assured that you're not actually going to affect the outside world. That's really hard in Java. That is really hard with an object graph to do in Java. Clojure has built into its libraries this notion of a software transactional memory, and it's really the ACI in ACID. It's just all of those semantics minus the durability. And really, to enable that, you need this sort of immutable, persistent data. And then to be able to do all that in a concurrent environment, you need immutable, persistent data. And then you have the notion that I alluded to before, and that is that state and identity are separate. So in my example that I gave, I passed in a map to a function and got a function out. Well, I passed a map to a function, and that function did some stuff to the map, and then passed out this different view of the map. And from the caller's perspective, they may decide that, yes, those things are the same, but in fact, they can see both sides of that state change. And so in Clojure, sort of one of the fundamental principles in Clojure is that state and identity are separate and they're viewed differently. In the Java world, it's just all sort of filed together into your object. And heaven help you if you want to be able to separate what a thing is from what its states have been over time. So this is one thing I really love about Clojure as I've gotten into it. And so who needs an IDE? Well, if you develop in Java, you do. Most of the Clojure development that what limited I do at work and what I do at home, I have a REPL, a build environment called Linigan that we'll talk about in a little bit, and I have a good editor. And I will not walk into the minefield of what defines a good editor, but I have the editor of my choice that has Clojure syntax highlighting, and it has some connection to a REPL. And that's the environment in which I live. And at first, that's really unnerving because you're leaving the safety of IntelliJ or Eclipse or NetBeans, and you're sort of walking out like, oh, where are all my tools? What do I do? How do I debug? And then you realize, oh well, I had to have a lot of that stuff because of the overhead of the language I chose to write in. Many of those IDE features are features because they're trying to overcome some inconvenience within Java. So, and really, a REPL and an editor and Linigan will get you a really, really speedy development cycle. So, because Clojure is a dynamically compiled language, you make a code change and save the file, hit the REPL. Does it work? Yes. Run some tests. Great, it works. And then you just move on with your life. We won't touch on this very much, but in the Clojure community, and this is maybe more of a feature of the community, there's lots of libraries. They focus on libraries rather than frameworks, and a lot of the libraries just fit together nicely because they obey a set of few conventions that are adopted, and they really do go a long way. And lastly, so Clojure is hosted. So you leverage all of what is great about the JVM. And you leverage all of the stuff listed here. And really, Clojure was able to bootstrap itself and get going with a pretty remarkable speed. The author of the language, Rich Hickey, says that, well, we solved the library problem of writing a new language by just essentially using Java's libraries where we needed to. So Clojure leverages that very heavily. The other cool thing about Clojure being a hosted language is that there isn't just one host. So there are other target platforms. Clojure CLR is Clojure on the CLR, and Clojure Script is Clojure running in a or in a JavaScript environment. So you can compile Clojure into JavaScript and run that in Node, for example. And those two are officially supported. They're young. They're not as mature as Clojure, but really the code you write for Clojure and the code you write for Clojure scripts are essentially identical. And then there's a whole bunch of others like Laser. That's I imagine you think it's interesting, Curtis Laser. That is, I think, ActionScript. And Rogue is Ruby, and you can compile it to Scheme, and you can compile it to C. Those are all, none of those are officially supported, so buyer beware there. But there is a lot that you can do with the same simple syntax. You know, and I'm going to skip through a lot of this. So Clojure is opinionated, and that was one thing that I really appreciated about Clojure. So I won't. This is a lot of Clojure and Rich Hickey's opinions, but I appreciated that it was that Clojure was opinionated. So I have my Scala book and I have my Clojure book, and one thing I realized I didn't really like about Scala, and this is just obviously my opinion, was that it didn't really take a stand about what they thought, what Odersky thought the right thing to do was. Because a lot of times when you're reading this book especially, he says, well, if you want to do object-oriented programming, great. Here's how you do all of that in Scala. Whereas if you want to do functional, well, you got to remember a little bit of this, and then you do all of that in Scala. And I didn't find that particularly appealing because it just sort of waffled. It didn't take a stand. The stand taken by Clojure was much more appealing to me personally. If you want to read about the opinions, you can read about them. I've covered a lot of it. And like I said, these tabs were not going to be the same size. And so what you need to do now to get started with Clojure is install Lineagen. And Lineagen is a build tool built on Maven. And what you need to do is install Lineagen 2x. And then you need to just experiment with the REPL. And that's what we have here. So I can just exit out of this. Now I've installed Lineagen on this machine. And I can just do line REPL, and the JVM will load, so we can take a nap. And go. Go. You can do it. Bootstrap. There we go. Wow, that was great. If you're on a Mac or Linux, that goes a lot faster. So, little plug there. So get yourself Lineagen. Run the REPL, experiment. Go through lessons 0 through 7. Try stuff. And then do all of this other stuff in whatever order you want to. And at the end of this, these slides will be available on the website. Here's a lot of stuff that you'll want to check out. So you start with Lineagen. You start with that build and project management tool, period. That's what you start with. And then read about Clojure and read the Clojure source, and that is actually really useful to start understanding it. There's some documentation sites. These are pretty cool because there are plenty of places online where you can actually get a REPL in a browser. Clojure script will allow you to run this REPL in the browser, so I can do exactly what I did before here, and it'll allow you to try stuff. That try-CLJ website that was somewhere, not there, here will actually take you through a tutorial of some of the language. It'll help you understand some of the libraries that are available, some of the functions that are available. And so that is very helpful. Then we have all sorts of, so this book right here is great. If you win one of the door prizes, you can buy it. Clojure Programming and The Joy of Clojure, I've read that one as well. Also very good. And I do highly suggest watching, if you're interested in Clojure, these two Clojure for Java programmers videos. They are long. They're quite long. I think it's like 3 hours total. But it is the language author and he walks through Clojure from the perspective of a Java developer. And then read the group. That's great. Lots of libraries, blah blah blah, and lots of IDE and editor support. And this will get you jump started into doing what you need to do. And really, that is, I guess, Clojure in an hour. Thank you. Appreciate it.
What I forgot to mention is that you wait till next month when Hack Night for Clojure, and he'll be here to answer all of your questions all night long. I'm sure there will be no questions. It will all be straightforward. The only last remaining thing that we have on our agenda tonight is our door prizes. So, because we are presenting on Clojure and we give out tickets, number of tickets, we needed a way to give the winning numbers. And so what would be the right way to give out the winning numbers than to have Justin write a little Clojure?
Let's see.
So, first one is -3.
Hang on. So start is 149390. Yes? Who has that one? Oh, I guess I have that one.
I'm on the edge of my seat here.
I know.
So, our very first prize is from O'Reilly Books is Clojure, the paperback. Everybody will enjoy it. So showing up with a good paperback book. And they're on their way here. So what we're going to ask you to do is we're going to do this one and write down your contact information on the line. In some cases, we're giving away software licenses, and I have to collect the contact information to type them in to the website so that the giver of the license can stand it.
Okay, hang on.
Did you appease the demo guy?
Does everybody see themselves in this list? Or vector, I should say? Are you there?
Yeah. Yeah. Oh, yeah. You look taller.
Are we ready?
We are ready.
Do we need a really lame drum roll? No?
No.
Yeah! Okay, and the winner is 149392.
149392.
Nice work.
The second Clojure paperback book goes to
That person, 149412.
all right, next we have
These results have been audited by one of the big four accounting firms. Trust me.
we have a J Rebel 1-year license. Or
Does anybody use J-Rebel?
if you haven't used J
Is
Rebel,
J-Rebel pretty awesome? I've heard. Yes? No, all right. That's a nice expensive piece of paper there.
if you haven't know, J Rebel is a great tool for allowing you to modify code, running code, modify executing code, so you don't have to restart this, redeploy your app in Tomcast or in the running application. It is super sweet.
And the winner is 149401. The man in the back. Whoa, Gary, what are you doing?
So close. J Rebel number 2.
Okay, that is 403. Jim.
Next, we have Structure 101, which is a design application. This is a perpetual license. Can't tell anything about this. We don't know.
They,
But tell that he's not.
But the lucky person is 402.
And its companion product, which is Restructure 101, which is a re-engineering or reverse engineering product. Again, no real experience.
394. Who is it? Nice work, David Johnson.
Now, we also have, besides our parts, our soft cover books, we also have 5 ebooks from O'Reilly of your choice. And they go to
396.
all right, okay.
393.
Oh, right here.
What? No. Rigged. Autos and test that one. Verify.
This is the case.
411. And do we have one more?
2 more.
405. And 391. Nice.
These particular companies have signed up to allow us to give out those numbers of items every presentation. So you want to remember to come back